In continuation to our previous discussion, that is classification of signals, today we will discuss the fourth type of signal, that is energy signal and power signals. We know that power is amount of energy produced or consumed for per unit of time. That's power is E upon T or measured in watts or joule per second. Joule is the unit of energy. Further, energy can be taken as power into time. So in the electrical scenario where voltage and current are there, we assume that variable is xt, maybe voltage or current. Then instantaneous power, we know that P is proportional to V square and P is proportional to I square. So x square T is the instantaneous power associated with the voltage or current. Now energy of the signal, suppose we have drawn the instantaneous power signal x square T here in graphical form with respect to time t, then if we have to find the energy of the signal, we just need to, because energy is what? Power into time. So we need to integrate this instantaneous power for the time duration, for the given time duration. Suppose we will integrate for the minus t by 2 to t by 2, then we will have the energy associated with this particular component. Okay. If we increase this limit for the whole minus infinite to infinite limits, that is for the complete spectrum, then we will have the total energy, that t tends to infinite becomes total energy, otherwise it is energy associated with this time period minus t by 2 to t by 2 with respect to instantaneous power of the signal. Similarly, time average power. If we have to find out the time average power, we have two methods. That first is find out the energy and divide it by time, or just from this figure you can see that energy associated with this particular time period minus t by 2 to t by 2 is this one, minus t by 2 by 2 x square t dt. That is integration of signal in this time period. And if we want to get the average power in this duration, then just we have to divide the energy associated in this part divided by period of this part. Again, I am repeating, the energy associated with this part divided by time period of this part, that is E upon T, that is energy of power of this time period. If we have to find the average power for the whole signal, then we have to again applying the limit t infinite, that is for the whole spectrum. Now it is the average power. This formula is for average power. Okay, so these are the major formulas used to identify the energy signal and power signal. Now applying the limit in first equation, t tends to infinite, the limits becomes minus infinite to infinite. It is easier to remember. E is equal to minus infinite to infinite x square t dt. And for periodic signal, suppose it is a periodic signal, obviously periodic signal is the signal having the same repetition for infinite duration of time from minus infinite to plus infinite, and the duration or time period which is known as, which makes it period, we can find the power for that period only, because it is the same for the complete duration. So for periodic signal only, average power can be find out by the this term only, because this is shown that it tends to infinite, and for periodic signal it doesn't mean to get for infinite, because it is extended to infinite obviously. So we will find the power associated with only one period of signal, that is energy per period of signal divided by time, that is average power. So this formula will be used when it is periodic signal. Otherwise, if it is non-periodic signal, then this formula will be used, and if it is any signal, then we will use this or this formula. Both are same, just applying the limits. Okay, so now the definition of energy and power signal. Energy signals are those signals whose total energy is finite and average power is zero. That is, energy should be finite and average power should be zero. And power signals are those signals whose power is finite and energy should be infinite. It is natural we will find the first component, and second component will automatically appear. So the signal that does not satisfy the above properties are neither energy nor power signal. It means there are signals which may be not energy nor power. It doesn't necessary that every signal should be an energy or power signal. It may be possible that it is not neither energy nor power signal. Some examples of energy signals are deterministic signals and non-periodic signals. The signals which can be determined by the formula, and non-periodic signals which are not periodic signals, and power signals are the signals which are periodic signals and random signals. Okay, so from this example we can easily identify that every non-periodic signal is energy signal and every periodic signal is power signal. Maybe it doesn't satisfy any criteria, then it will come in this third criteria, neither energy nor power signal. So first we will find out the some examples. That suppose it is example xt is a signal from here 0 to 1, it varies from it is t, the time t, and from 1 to 2 it is 2 minus t, and otherwise it's 0. So the signal essentially has some value in between 0 to 2, otherwise it is 0. So that's why it is a non-periodic signal, because it only has values from 0 to 2, but in periodic signal it should have values for infinite duration of time. So it is non-periodic signal, so it must be energy signal. So just finding the energy of the signal by the formula, putting the integration sign and putting the limits, and it will become 0 to 2 obviously, and then breaking the limits 0 to 1 putting the value of t, and 1 to 2 putting the value of 2 minus t, and you have the integration, it is 2 by 3. So energy of the signal is 2 by 3. Second example, just by looking you can find the it is energy or power signal. Second example, suppose xt is equal to 5 cos pi t plus sine 5 pi t. It is obviously cos and sine are periodic functions, and it also extend from minus infinite to infinite duration, so it is a periodic signal. Suppose it has the same expression, but it is now minus 5 to 5, then it will be non-periodic signal, because now limits are not period infinite. Okay, both the conditions should be satisfied. So it is a periodic signal, so it must be power signal. And finding the power of the signal 1 upon t minus t by 2 to t by 2 x square t dt, and putting the value of this signal here and solving the expression, it comes out to 13. So it's a power signal. So just by looking at the limits, looking at the type of signal, we can identify the whether it is periodic or whether it is energy signal or power signal. Now energy and power signal for discrete time signals, it is same, because in discrete time domain we have samples, so integration is to be converted into summation form. All other things are same. E is equal to summation n equal to minus infinite to infinite x square n, and average where there is integration, it is now summation again. Where there is a capital T, it is now capital N, fundamental time period for discrete time signal. Small n is the time samples of in discrete time domain. So it is an expression limit n tends to infinite 1 upon 2n and varies from minus 9 to n to n x square n. Okay, for periodic signal again we need not to have this limit, because it is always infinite signal, periodic signals. So it is the average power. Further, this can be written as in single form, that is if period is now less, that is 1 upon 2n is now is 1 upon n, then it limits become minus n to n will become 0 to n minus 1. So both are expressions are equally good and equally applicable. Okay. Now some examples of discrete time signals are, suppose xn is cos pi n. Cos is a periodic signal, so it must be periodic signal, but limits are minus 4 to 4. Now limits are not up to infinite, so it is a non-periodic signal. So every non-periodic signal is almost an energy signal. So finding the energy of this signal, and minus infinite to infinite x square n is equal to 9. Similarly, second example xn, here again the same signal, but now it varies from 0 to infinite. N is greater than 0, so it is a periodic signal. So periodic signals are power signals. P is equal to 1 up, finding the power of the signal from this formula, and it comes out to be 1 by 2. So it is power signal. Maybe some signals are there. It seems they are periodic or non-periodic signals, but it comes out that their power and energy are zero. For example, xn sine pi n minus 8 n 8 to h. So obviously it seems periodic from here, but it seems aperiodic from here because it has some distinct limits. Now it looks non-periodic from these limits. So finding the energy of the signal, energy of signals comes out to be zero. So we find out that it is neither energy nor power signal because it has zero power and zero energy. That's why we call it a zero signal. So maybe this type of signals we can encounter that whether they are neither zero nor power. All periodic signals are power signals. Classification of signals: deterministic and random signals. There is no uncertainty with respect to time. Xt is equal to sine pi t. That is, if deterministic signals are those signals, if we know at any moment of time what will be the value of signal, there is no uncertainty with respect to time. Okay, we know at value of t equal to any value, we know the value of xt. T equal to 5, t equal to 7, we know the value of xt. That is, there is no uncertainty. We are fine. We are deterministic. We are sure. In random signals, there is uncertainty before it occurs because we don't know what will happen, what will the value in the next instant of time. That is an example, noise or electrocardiogram signals, EEG signals. So actually random signals are used to study these type of signals, especially noise signals are assumed to be random signals, and then we use the random process, random theory, and study the random signals. Next classification is causal and non-causal anti-causal signals. Three types. Causal signals are those which does not exist in negative time, that is only exist in positive time. X is 0 for negative. Anti-causal are signals which does not exist in positive time, only exist in negative. Non-causal signals are both signals which are neither causal nor anti-causal, that is it exists between positive as well as negative duration of time. Okay, looking at like this example. So these are the classification of signals. That's all for this session, that's classification of signals. And now we will cover the systems in the next lecture. Thank you very much for watching.